All right, this is the first of two videos. The first video that you watch is going to be on page 4 of your notes. It's the explanation of the tangent line problem. This is a famous problem throughout math history that mathematicians have tried to solve, and it actually leads to one of the major things in calculus. So we're going to figure out where the equation came from and end up down at the bottom with the equation. The second part of this will be solving problems using the equation. So the first video is page 4, the second video is page 5. For this, you're going to need a ruler. We're going to use it not to measure, but as a straight edge, so you can really use the side of a book or whatever. But the tangent line problem goes like this. We want to draw a line that's through a point on a curve and that's tangent to, and when we say tangent, I don't mean SOHCAHTOA or opposite over adjacent, but in this case, the word tangent means touches at only one point. So I want to draw a line that goes through the point on the curve that's right here, but only touches the curve at one point. So I'll draw this. It's an estimate, so if we all have different answers, that's no big deal. If your lines probably will be different than mine, and that's actually part of the problem that we're dealing with. If I want to find the slope of this line, I'm going to estimate. It doesn't hit 1, 0 perfectly, but that makes for some nice, easy math. So I'm going to call 1, 0, the other one 6, and man, it's not exactly 4, but we'll call it 6, 4. 6, 4 up here. Close enough. So if I wanted to estimate the slope of this line, I'm going to go 4 minus 0, 6 minus 1, like that. And we get 4/5 for a slope. If you have a different slope, no big deal. That's actually part of the problem, is mathematicians try to figure out what is the actual slope. And if you eyeball, you're going to get one answer. I'm going to get a different answer, and who knows who's right. What can actually help us with this is our limits, and that's what we've been studying. So here's the logic of what we're going to do. This is the x-axis, so we're going to call these our x's. Up here's the y-axis, or in function notation, y and f of x mean the exact same thing. The point right here, I'm going to call this the point x, comma, instead of y, I'm going to use the function notation of f of x. Or the better way to think of it is x and x after a function has been applied to it. Now what I'm going to do is I'm going to pick another point up here on the curve, and I'm going to connect those two dots with a ruler. Now when I do that, this is not a tangent line because it hits at 2 points, not 1 point. But here's what I'm going to say. I'm going to say the x value has been moved over a little bit. We don't know exactly what that number is, but we're going to say x. We're going to scoot you over h, in general, just h. So if I start at x and I move over h, we're going to call that x plus h. The y value, the way we thought of it was x after it's been run through function f. So the y value is, now we're going to take this and run it through function f. So this would be f of x plus h. So that point will be run through function f. So I have 2 points. It's not a tangent line, but what we can do is we can calculate the slope. We can calculate the slope once we have 2 points. So I'm going to go this y value minus this y value. So I'm going to call it f of x plus h minus f of x. And then y minus y. And then I'm going to go x, which is x plus h, minus this x value, like that. So y minus y, x minus the x. And that's the formula that we're going to use. What we're going to do now is we're going to look at how limits tie into this. Well, the good thing about what we just did is we can calculate the slope because we have 2 separate points. The bad thing is that it's not right because this line is a tangent. It goes through 2. Well, here's through 2 points. Here's the logic we're going to use. If I take this point and I make h a little smaller, if I pick a point that's closer to this other point and I find the slope of that line, it's still not the slope of the tangent line because it goes through 2 points, but we're going to say it's a little bit better. It's a little bit better than the line before. Or if I go to the third one, and now I'm going to pick an h value, or the difference between those, and I'm going to make it even smaller yet. So pick 2 points that are right next to each other, and I'm going to connect those 2 dots. Okay, it's still not right, but we're going to say that one's even better than the one before. the logic goes like this, that if we can take that h value and make it smaller and smaller and smaller and smaller and smaller until it's basically 0, that we'll have the slope of the line at that tangent point. So the equation is going to go like this. We're going to find the limit as h approaches 0. So as that distance between the points gets really, really, really small, really it's just going to be the slope. So on top, I'm going to use this equation that we have right over here. X plus h minus f of x. On bottom, if I simplify, here I have x plus h minus x, so it's just going to be h. And that's where the equation comes from. In the next video, we're going to use this equation over and over again, but it basically goes like this. This is the distance between your 2 points, so we can calculate the slope as the distance between the points gets really, 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 really small until the distance between the points is basically 0. Then we'll have the slope at that one point. All right, watch it again if you need it. Otherwise, you can work on some problems on the other side. We'll try.